Chapter 5, we learned about two-digit addition. Guess what we're learning about in Chapter 6 today? Two-digit subtraction! So, just like how we started with adding tens, we're going to start with subtracting tens. It's really not all that different. Instead of adding, you just subtract. And since we did single-digit subtraction, it shouldn't be that hard. You use basic facts to help you subtract tens, just like how you would use basic facts to help you add tens. Since 6 minus 1 equals to 5, you know that 60 minus 10 equals to 50. 6 tens minus 1 10 equals to 5 tens. Now let's do some practice problems. 90 minus 40. That's 9 tens minus 4 tens. So 9 minus 4 is equal to 5. So that's 5 tens, which is 50. 20 minus 10, 2 tens minus 1 10 is equal to 2 minus 1, and that's 110. So that 110 is just 10. 40 minus 30, that's 4 tens and 3 tens. So 4 minus 3 is 1, 110, and 110 is again just 10. 80 minus 50, 8 tens minus 5 tens. What's 8 minus 5? 3. This is why it's important to remember your single-digit subtraction too. And, well, it's 3 tens, so it's 30. 70 minus 30. Well, you see, 70 is 7 tens and 30 is 3 tens. So 7 tens minus 3 tens is equal to 7 minus 3, 4, 4 tens. 4 tens is 40. 30 minus 10, that's 3 tens minus 1 10. And 3 tens minus 1 10 is 3 minus 1, 2 tens. So 2 tens is 20. Alright, so as you can see, it's not all that different from addition, except it's just, well, subtraction. It's not all that different from two-digit addition. Two-digit subtraction is similar to normal subtraction, just like how two-digit addition is just normal addition. Anyhow, moving on to the next section. Now, counting back tens and ones is not the preferred method. I don't like doing that because, again, as I've mentioned before, you don't get number lines after grade 3. In fact, I don't even think we got number lines in grade 3. Anyways, how do we count back? We're not going to count back just completely, just one by one. If there's tens, you count by tens or count by ones if there's ones. Such as 72 minus 2. There's no tens to count back because 2 is smaller than 10. So what's 72 minus 2? Well, you count back 2. 71, 70. So that's 70. You've counted back 2. 38 minus 20. Well, there's not really much in the ones. It's a 0. So we're going to count back by tens. So from 38, we count back 1 10, and that's 28. And then we count back another one because there's 2 tens, and we get 18. $69 minus 30. There's 3 tens to count back this time. So 5 is 1 before 6, and then 4 is 2 before 6, and then 3 is 3 before 6. So that's 39 because there's nothing in the ones place. 27 minus 4, well, 6, 5, 4, 3. 23. Okay, we won't really be using this very much because you need a number line, or you need to actually get your fingers out and count. It just takes longer. So how are we going to do this? Well, let's find out. But before we do that, we need to talk about regrouping. Now, in addition, you regroup when there's more than 10. Here, you regroup when, well, you need a bigger number to subtract, such as 57 minus 19. Okay? So you line them up just like you do in addition, but instead of putting a plus sign, you put a minus sign. And you subtract the ones. But, oh no! 7 minus 9. How does that work? It doesn't. Well, at least not in grade 2. So what do we do? Well, you see, there's 5 tens here. We're going to borrow a 10. So we cross out the 5, and it becomes 4. And then you add a 10 to the 7. And the 7 becomes 17. So this is 4 tens and 17, which is equal to 5 tens and 7, which is 57. Now, 17 minus 9. Does that work now? Yes. 17 minus 9 is equal to 8. All right, so that's the ones place done. Now, what about the tens place? Well, we took 1 10 out of the 5 to, well, give it to the 7. Now we have 4 tens left. What's 4 minus 1? 3. Our answer is 38. So Leon originally has 57 coloring pencils. That's a really interesting number, because usually they sell them in packs of 24 or 48 or 50. Not 57. Maybe he lost a few. After 2 weeks of school, he discovers he has lost 19 of them. This is why. How many coloring pencils does he have left? So we did the calculation, and we got that Leon has 38 coloring pencils left. So when you regroup in subtraction, you're borrowing numbers, basically. Now we're going to do a few practice problems. Coco bakes 64 cookies. 28 of them are not chocolate chip. How many chocolate chip cookies are there? So that's 64 minus 28. What's that? Well, we have 64 minus 28. Remember to line up the place values. In the ones place, start with the right side. We have 4 minus 8. That doesn't work. So let's regroup. We take 1 away from the 6. The 6 becomes a 5. And then we get 14 minus 8, which is 6. Okay, guys, remember that 5 tens and 14 is equal to 5 tens, 1 10, and 4 ones, which is equal to 6 tens and 4 ones, which is equal to 64. Okay, this is still the same number. They're just borrowing stuff to the ones place, because we need to do the subtraction properly, and we need to regroup in order to do the subtraction properly. Okay, now we've got the ones place down. And we're doing the tens place. 6 had 1 regrouped out of it, meaning that it is now 5 tens. 5 tens minus 2 tens is 5 minus 2, 3 tens. So that's 36. There are 36 chocolate chip cookies. Okay. Kate has 81 lollipops to hand out. She hands out 53 of them. How many does Kate have left? She originally has 81, so that's 81 minus, she hands out 53, minus 53 equals to, that's the amount that Kate has left. So 81 minus 53, we line them up, start from the right. Oh, look, for ones, we have 1 minus 3. Does that work? No, we can't do that. So, what are we going to do? Well, regroup. So we take 1 from the 8 tens, so 1 10 from the 8 tens, and it becomes 7 tens. And then 1 10 and 1 is 11. That's 11 minus 3 now. Does 11 minus 3 work? Yes. We get 8. Okay, now the ones place is done. 7 minus 5 is what's left in the tens place because the 8 borrowed 1 to the ones place, becoming 7. 7 minus 5 is 2. 28. So Kate has 28 lollipops left. Make sure to spell everything right. You could totally spell lollipops with, You know, sometimes in English there are things that are spelled very weirdly, and we can't do much about them. So make sure that everything that you write is spelled right. Sometimes a spelling mistake can, well, make your answer wrong. And you don't want that because you worked for that answer. Jason has 33 marbles. He loses 16 of them. What's with these children and losing their things? How many marbles does he have now? Actually, we don't know if they're children or not. But what's with these people and losing things? Anyways, 33 is the original number. They lose 16 of them. And that becomes 33 minus 16. And we line them up. Our ones place is 3 minus 6, which doesn't quite work. So we regroup. And we get 13 minus 6. And what's that? 7. When you regroup, you only need to regroup 1, okay? Do not regroup, say, 2 and become 23 minus 6 because that would be more than 10, and then you need to regroup again, which makes everything a lot more complicated. So when you regroup, only regroup 1, whether it be 110, 100, 1000, only regroup 1. You can regroup multiple times, but when you regroup, only regroup over, say, 110 or 100. Don't do 210. Don't do 310. None of that. Anyways, because you regrouped, you now have 2 tens minus 1 10, which is 110. Together, we get 110, 7 ones, which is 17, and Jason has 17 marbles now. You can also write, Jason now has 17 marbles. Just make sure that your sentence is grammatically correct. Alright, that's the regrouping section done. Now we can move on to the next one. Here we get to write a number sentence. Nathan eats 5 carrots for lunch. He eats another 6 carrots at dinner. I really hope they're baby carrots because carrots can be pretty big. How many carrots did Nathan eat? So what do I know? 5 carrots for lunch. What else do I know? 6 carrots at dinner. What do I need to find out? How many carrots did Nathan eat? Which means how many carrots in total? Our plan, how will I solve this, is, well, the strategy is already written for us. Write a number sentence. Now let's actually solve it. Since it's a total, it would be addition, so 5 plus 6, and that's equal to 11. Nathan ate 11 carrots. Okay. Now we check our answer. Is our information correct? 5 carrots for lunch, 6 carrots at dinner, 5, 6, okay. That's good. Have we answered the question? How many carrots did Nathan eat? Nathan ate 11 carrots. Yes. Is our math correct? 5 plus 6 equals to 11. That is true. It's all correct, all in order, so our answer is correct. Now, let's move back into subtraction. Okay, so subtracting 1-digit numbers from 2-digit numbers, really, you just need to line things up and maybe do some regrouping. Okay, so you line them up, you have 1 and 3 for your ones place. Does that work? 1 minus 3? No, you have to regroup and you end up with 11 minus 3, which is 8. And then there's 5 minus nothingness, which is just 5 for the tens place, and that's 58. Of course, you don't actually need to cross out the 6. I've done these calculations plenty of times where I just did this. You just have to remember that this means that there's a regrouping going on. So if you can remember, then you don't need to cross it out. But if you can't, then go ahead and cross it out. Now subtract 93 minus 1. You take away 1 from 93. 3 minus 1, 2. 9 minus nothingness, 9. That's 92. All right. 67 minus 9. The ones place is 7 minus 9, which, well, doesn't really work, so we need to regroup. And we get 17 minus 9, which is 8. Now, since we regrouped away from 6, 6 becomes a 5. But 5 minus nothingness is, well, still 5. So it's 58. 80 minus 6 is, you line them up, start from the right. 0 minus 6. Doesn't really work, right? So you borrow 10 from 8 tens, and it becomes 10 minus 6, which is 4. Now 8 tens got 1 10 taken away from it, so now it's 7 tens. And 7 tens minus nothingness is still 7 tens. That's 74. 80 minus 6 is 74. All right, so let's move on. 28 minus 2. You line them up, and 8 minus 2. You don't need to regroup for that. So 8 minus 2 is 6. And then 2 minus nothingness is still 2. That's 26. 36 minus 7. You line them up, and for the ones place you get 6 minus 7. Does that work? No, you need to regroup. So after you regroup, you get 16 minus 7, which is equal to 9. Now, 3 tens got 1 10 regrouped out of it. Now it's 2 tens. To make it clearer, I'll just cross it out and write the 2. You don't need to cross it out and write the 2 if you can remember. But it does help if you can't remember. Now 2 minus nothingness is still 2. That's 29. 11 minus 4. If you remember your single digit addition and your families, then you should remember what the answer to this is. But let's just do it. 1 minus 4 is our ones place. That doesn't work, so we have to regroup. And then we get 11 minus 4. Still 11 minus 4. So it's 7. Now there's nothing, because there was only 1 10 in the tens place, in the tens place. So that's 0. You don't need to write down to 0. And we get the answer 7. All right. You can take a break whenever you want. Remember that. Now we subtract 2-digit numbers. It's not all that different from subtracting 1-digit numbers from 2-digit numbers. It's just that you have to take care of the tens place this time. Now we have 64 minus 39. We line them up, and the ones place, remember, start from the smaller place value, smallest place value actually, and it's 4 minus 9, which means that we have to regroup. And it becomes 14 minus 9, which is 5. Now since we regrouped, the 6 is now a 5. What's 5 minus 3? They're still in the tens column, so what's 5 minus 3? 2. 2 tens. We get the answer that 64 minus 39 is equal to 25. Now let's do some other questions. 18 minus 12. We line them up. We start from the smallest place value, and that's the ones place. 8 minus 2, we don't need to regroup for that, and that's just 6. We move on to the tens place. 1 minus 1 is 0. We don't need to write it down, because 0, 6 is the same thing as just, well, 6. So our answer is 6. 92 minus 68. Minus 8 is our ones place. We need to regroup for that. So we regroup. Now you can probably tell the second reason why I don't like, remember back in the addition chapter, last chapter? I don't like putting the regrouped one up there, because then it looks more like subtraction. Just to me, though, you can still do it that way. So 10 plus 2 is 12. 12 minus 8 is 4. And since 9 got 1 taken out of it, 9 is now 8. 8 minus 6, because they're still both in the tens column. 8 minus 6 is 2. Our answer is 24. What about 53 and 43? 53 minus 43. 3 minus 3. Subtract all. Remember what happens when you subtract all? You get 0. Nothing. So we move on to the tens place because that's the ones place done. 5 minus 4 is 1. Our answer is 10. 47 minus 25. You line them up. You start from the right, and you get 7 minus 5. Do we need to regroup for that? No. Now, if you haven't realized this by now, you only need to regroup when the number on the top, or the original number, is, well, smaller than the number on the bottom. Such as 2 is smaller than 8, and 4 is smaller than 9. Okay, 7 minus 5. It doesn't need to be regrouped, so 7 minus 5 is just 2. And 4 minus 2 is also just 2, 22. 21 minus 17. You line them up, and the ones place, we have, 1 minus 7. 1 is smaller than 7, so you already know that you need to regroup. You regroup, and you get 11 minus 7, which is 4. And because you regrouped, 2 is now 1. What's 1 minus 1? 110 minus 110 is 0 tens. You don't need to write the 0 there. And you end up with just 4. 79 minus 54 is, well, 9 minus 4. 9 is bigger than 4. We know this is going to work. We don't need to regroup. So that's 5. And 7 minus 5 is 2. 25. Well then, that's the end of, well, this section. You can take a break whenever you want. And now we're going to move on to the next section. Unless you're taking a break. How do we check subtraction? Except, well, just looking over it. In math, you can use the opposite operation to check your answers. Now, when we first introduced subtraction, what did we tell you? Subtraction is the opposite of addition, which means that when we do subtraction, the opposite operation would be addition. And when we do addition, the opposite would be subtraction. So when you subtract, you can check by adding. Let me show you. 45 minus 24. Okay, so 5 minus 4, 1, 4 minus 2, 2. Okay, how do we check this? So we take 24 and we take our answer, 21, and we add them. And we get 45. So if we take away 24 from 45, we get 21, which means that if we add 21 and 24, we should get 45, which we do. This is also related to the fact families. Okay, so let's do some subtraction and checking by adding. 71 minus 32. 1 minus 2 is in the ones place, and, well, we can tell right then and there that we need to regroup. 11 minus 2 is 9. And since 7 got 1 regrouped out of it, it's 6 now. 6 minus 3 is 3. We get 39. But we have to check. So 39 plus 32, if we are right, then this should equal to 71. 9 plus 2, 11, we regroup because 11 is bigger than 9. It's 10 or bigger. And 11 is definitely bigger than 10. 3 plus 1, that's 6 plus 1, that's 7. 71. Our answer is correct. So 71 minus 32 is equal to 39. What about 68 and 58? So 68 minus 58, the ones digit, 8 minus 8, 0. 6 minus 5, 1. Okay, if the answer 10 is correct, then 58 plus 10, you might realize that I'm switching around the order of like the answer and the original number in the subtraction operation. Well, that's because commutative property of addition. This should equal to 68. And 8 plus 0, 8, 5 plus 1, 6. It is! So our answer is, in fact, 10. Moving on. 32 minus 18. So when we line them up, we get 2 minus 8. Meaning that we have to regroup, and after we regroup, we end up with 12 minus 8, which is 4. And since we regrouped, 3 is now 2. So 2 minus 1 is 1. We get 14. But is it 14? Is it? Is it? Is it? Well, let's check. 14 plus 18 is 4 plus 8, 12, regroup, 1 plus 1 plus 1, 3. It is! So our answer 14 is correct. Now, 56 minus 25. We line them up, and our ones place is 6 minus 5, which is 1. 5 minus 2 is 3. 31. Is it correct, though? 31 minus 25 is not what we're supposed to do, because opposites. We need to use the opposite operation. So that's plus. Remember, guys, please use the opposite operation. If you use the same operation, you're not going to get very far. Now, 1 plus 5 is 6, and 3 plus 2 is 5. So it is 56. It seems that the answer is 31. Hooray! So the takeaways from this lesson are that when you check your answers, you can use the opposite operation. For subtraction, this is addition. For addition, this is subtraction. And if this looks familiar to you, this is related to the fact families that we learned a few chapters ago. Okay. Our next section is a problem-solving investigation. You can take a break if you want. We get to choose a strategy. Lauren counted 15 flavors at Jimmy's ice cream parlor. She counted 27 other flavors at Martha's frozen yogurt shop. How many flavors are there in all? What do I know? Well, there's 15 flavors at one place and 27 other flavors at another place. What do I need to find out? How many flavors are there in all, so in total? Now this word other is actually very important because both shops could have vanilla and that would count as one flavor. But other flavors means that there aren't repeats that can make our problem-solving journey more difficult. So how will I get my answer? Let's write a number sentence. 15 and 27. So it says in all, which means that it's addition. If it says how many more are there at Martha's than at Jimmy's. Well, it says 27 other flavors, which means that there's 27 more. That's a logical reasoning problem. But some words will tell you whether or not to add or subtract or do something else. Now, what's 27 plus 15? We line them up. We start from the right side, and we get 7 plus 5. What's 7 plus 5? 12. Meaning that we have to regroup, and we get 2 plus 1 plus 1, which is 2 plus 2, which is 4. There are 42 flavors in all. Okay, so we move on to step 4. Check. Make sure the information is correct. So 15 flavors at Jimmy's and 27 other flavors at Martha's. Okay, make sure our math is correct. 27 plus 15. Well, remember what I said about fact families and opposite operations? We can use subtraction. So what's 42 minus 15? It should be equal to 27, if 42 is the right answer. Well, 2 minus 5 doesn't work, so we have to regroup. And 12 minus 5 is 7. 4 got 1 regrouped out of it, so now it's 3. 3 minus 1 is 2, that's 27. So our math is correct. Did we answer the question though? What's the question asking us? How many flavors are there in all? There are 42 flavors in all. We answered the question. So our answer is correct because our information is correct, our math is correct, and we answered the question. Now that we're done our problem solving, estimate differences. Now we know what an estimate is now, an educated guess, an answer that is supposed to be close to the exact answer, but well, sometimes isn't as close as we want. And when it is used, you estimate when you don't need an exact answer, or, just going to tell you guys this, but you can also use estimating when you want to check your answer and see if it's around the right place. Which means that you didn't make a horribly wrong mistake. There are 76 pretzels in a bag of party mix. Corey eats 58 of them. How many pretzels are left? Okay, I've never personally understood this, but a lot of people don't like the pretzels in party mixes. Personally, I like them. I like the other parts too, but I also like the pretzels. A lot of the people eat the other parts first and they leave the pretzels there and stare at them. So now that we've got our numbers written out, let's round. What does 76 round to? Well, remember our rounding lesson? Numbers 5 and up, round up, and numbers smaller than 5 round down. So 6 is larger than 5, we round up, and since it's 70, you round up to 80. And 58, well, 8 is also bigger than 5, so since it's 50, you round up to 60. Now, we subtract and we get 20. The step 2, subtract, was this part where we subtracted. But personally, I want to find out how good my estimation was. So what's 76 minus 58? 6 minus 8 doesn't work. You have to do some good old regrouping. And 16 minus 8 is 8. 7 becomes 6. 6 minus 5 is 1. And that's, well, 18. So 18 ends in 8. You round up to 20. Oh, it's pretty close. It's a pretty good estimate. Now, let's do some practice problems. Round these numbers to the nearest 10 and estimate the difference. Okay, 63 minus 41, okay. So they both end, because it's nearest 10, we look at the ones, and both of their ones places are smaller than 5, which means we round both of them down. And that becomes 60, that becomes 40. We subtract, and we get 20. So what's the exact one? What's the exact difference? Well, 3 minus 1 is 2, 6 minus 4 is also 2. 22. Yeah, you round that down to 20. That's not a bad estimate. Oh, 85 minus 24. 85 minus 24. 85 has 5 in its ones place, which means that if we are rounding to the nearest 10, we round up, and we get 90. 24, though, has 4 in its ones place. When we round to the nearest 10, we will be rounding down to 20. And then we subtract and we get 70. But what's the actual answer? 5 minus 4 is 1, and 8 minus 2 is 6. We wouldn't round that to 70. Sometimes, well, estimates aren't as accurate as they should be. And because estimates are educated guesses or are only around the number, we don't use estimates when we need to find an exact answer. Estimates are only used when you need to find a round number. A real life example would be going to the store and estimating if you have enough money to buy something. Now 58 minus 39. Both of these numbers have, well, numbers that are 5 or bigger in their ones place, which means that both of these numbers are going to be rounded up. 58 is going to become 60, and 39 is going to become 40. 60 minus 40 is 20. What's the actual answer, though? 8 minus 9 is, well, that doesn't really work. We have to regroup. 18 minus 9 works, and that's 9. 5 got 1 regrouped out of it, so that's 4. 4 minus 3 is 1. 19 is actually very close to 20. It's 1 off. This is a good estimate. 34 minus 19. Now 34 has 4 in its ones digit. 4 is smaller than 5, meaning that we will round it down to 30. 19, however, has 9 in its ones place. 9 is bigger than 5, meaning that we round up to 20. 30 minus 20 is equal to 10. What's the actual answer? Now 4 minus 9, well, we have to regroup for that. That's 14 minus 9, which is 5. And 3 has 1 regrouped out of it, so now it's 2. 2 minus 1 is 15. 15 is technically halfway between 20 and 10, but we would round it up to 20 instead of rounding it down to 10 because it ends in 5. So this isn't exactly a good estimate, but it's not as bad as this one because this one's 9 off. This one's 5 off. This one's only 2 off and this one's 1 off, so these are good estimates. This one is in the gray area of good and bad. So it's bad, but it's not terrible. This one just isn't that great. So, that's it for subtraction. Two-digit subtraction. That's it. And which means that's it for this chapter. I'll see you chapter 7. Don't forget to do your homework and practice problems.